Hey everyone, thanks for tuning in. Today we're going to be looking at the gradient of intervals and lines. So what we're going to be doing this lesson is just taking a look at the derivation of how we actually come up with the gradient formula, taking a look at how to actually apply it in a certain example, and also taking a look at collinear points and what it takes to define collinear points and looking at an example of those. Okay, so let's begin. So the first thing we look at is essentially the definition of what the gradient is, and that's rise over run. So it's how much we are rising over how much we're running. Okay, and whenever we read graphs, we read them from left to right. Okay, so what I'm going to do is start off with 2 points. I'm going to say this point here, and maybe this point here. Okay, and this point down here I'm going to define as x1, y1, just indicating that it's any point on the axis, and this point here is x2, y2, indicating yet again any point that's not the same as this. Okay, so these can be anywhere. Now, if we consider the line between these 2 points, okay, if we consider the line between these 2 points, right, we have got we can consider the gradient, and how we're going to do that is we're going to split it up in a right angled triangle. Okay, so we can construct a little right angled triangle and realize that the rise is going to be the vertical height of the triangle, and that the run is going to be the horizontal length of the triangle. Okay, and basically, well, what is this vertical length? And this vertical length is equal to y2 minus y1. And the horizontal length is going to be equal to x2 minus x1. Okay? And how we can kind of make sense of this is that the vertical height is going to be the distance from 0 to up here, so y2, and then we subtract that from this distance here, which is literally y1, okay, and the resulting length that we get is this one over here, and by a similar argument, that's how we get x2 minus x1 on the horizontal lengths. Okay, so now that we know gradient was previously defined as rise over run, our rise was this, and our run is this. Remember, we're reading from left to right. Okay, so because gradients rise over run, we're going to say m, which is just the symbol that we use for gradient. That's equal to our rise, which is y2 minus y1, over the run, which is x2 minus x1. And that is our formula for gradient. Okay? So what we're then looking at is, well, how do we define what's a positive gradient, what's a negative gradient, what is a zero gradient and an undefined gradient. So I'll start with positive and negative. So positive gradient literally means that the line is going like upwards from left to right, okay? And the negative gradient indicates that it's going downwards, okay? So this should be pretty simple. Then we look at zero and undefined gradient. So a zero gradient is something which is flat, and an undefined gradient is something which is vertical. Now, how we can make sense of why this is zero and why this is undefined is if we look back at the formula. So if we see a zero gradient is flat, okay, indicating that we have the same y value. Okay, so we have the same y value. So it's going to be y2 minus y1, which is going to be basically y2 minus y2, which is going to get a 0 on the denominator over whatever it is on the, a 0 on the numerator over no matter like what it is on the denominator. And so 0 over anything except 0, but obviously hopefully we can piece together that the horizontal length is not 0. So 0 over whatever is just going to be 0, and that's why our gradient is going to be 0 when we have a flat line of a horizontal line. Now, how do we get an undefined gradient? And how we're going to get this is if we look at the x values. So the x values between a and b don't change. Okay, it's actually the same x value. And because it's the same x value, then we're going to get a 0 on the denominator. Okay, and that essentially means that we're going to be dividing by 0. And what we should know is that we can't divide by 0, and hence that's going to be undefined. If you put it in a calculator or something like that, whenever you're dividing by 0, it will give you some, math error or something like that. So let's just look at a very, very basic example, which says find the gradient of the interval AB, where the point A is 5, negative 2, and the point B is negative 3, 4. Okay. Recalling our formula, which says that gradient, which is m, is equal to y2 minus y1 over x2 minus x1. Our y2, I'm just going to say, is 4, and then y1 is going to be negative 2, x2 is going to be negative 3, and x1 is going to be 5. So subbing what's relevant in the formula, we've got y2 minus y1, which is 4 minus 2, all over x2 minus x1, which is minus 3 minus 5. Okay, and that's just going to be 4 minus 2, which is 4 plus 2, which is 6, minus 3 minus 5 is negative 8, and what we're left with is negative 3/4. Okay, so that's quite simply essentially how you do the gradient. Okay, now what we're going to be looking at is collinear points. Okay, and how are we going to define collinear points? So we say that points are collinear if they all lie on the same line. Okay, so an example of a collinear point would be, of several collinear points would be if we had some sort of line and we had a point here, a point here, and a point here. These would all be collinear points. But if I was to add this point over here, that would not be a collinear, like these would not be a set of collinear points. Okay, because this one over here does not lie on the same line. So how are we going to test for collinear points? Okay, so let's screw that one and assume that we had these 3 collinear points. How do we actually prove that they're collinear? And what you should notice is that if they're on the same line, then this line is going to be, then the gradient from this point to this point is going to be equal to the gradient from this point to this point, because it all lies on the same straight line. So that's what we're going to be doing when we look at an example like this. So show that the points A, negative 2, 5, B, 1, 3, and C, 7, negative 1 are collinear. Okay, so all we need to do is show that we've got 3 points, A, B, and C, and we need to show that the gradient between them is equal. So find the gradient from A to B and the gradient from B to C, and if they're both equal, then that will suffice. Okay, so that's exactly what we're going to do. We're going to define the gradient of A to B. Remember, y2 minus y1 over x2 minus x1, so 3 minus 5 over 1 minus 2, so 1 plus 2. And that's going to be negative 2 over 3. So that's our gradient of the line AB. And then now what's the gradient of the line BC? And that's equal to, yet again, y2 minus y1 over x2 minus x1. So it's going to be negative 1 minus 3 over 7 minus 1. And that's going to be equal to minus 1 minus 3 is minus 4 over 7 minus 1 is 6. And that simplifies to negative 2 over 3. So because they're equal, then we can conclude that they are collinear. Alright. However, you didn't have to do specifically A, B, and B or BC. You could have done the gradient of AC. So let's just do that just in case. So the gradient of AC is equal to negative 1 minus 5. So negative 1 minus 5 over 7 minus 2. 7 minus 2. And that's going to be negative 6 over 7 minus 2 is 7 plus 2, which is 9. and that is negative 2/3 yet again. Okay, so moral of the story here is that if you need to prove that points are collinear, then all you need to do is consider the gradient between two sets of points. So A, B, BC, or AC. So any two of these three here. Okay, and that should be enough. So yeah, that's basically how we define the gradient and how we've defined collinear points. Okay, so this is an application from gradient. I don't think it's too difficult, and it should be relatively simple. So I hope you learned something, and I'll leave you with that.